Hello everyone, welcome to this fifth video on power spectral density. This video will help you to solve problem on cross power spectral density. As such, there is no need to worry. We have not much difference between power spectral and cross power spectral. The process and all the working procedure remains to be the same. Just the one thing which we need to keep in mind is going to be the change in formula that happens. Remaining all the quantities are going to be treated in a similar fashion to how we treated a power spectral density. So cross power spectral is as easy as your power spectral density. The problem now here is the cross power spectrum of a real process has been given to us. It is a combination of x and y, so two different quantities, hence we call it as cross. So we have sxy instead of sxx, and the function is a plus ib omega for mod omega less than or equal to 1 and 0 elsewhere. So if sxy has been given, we will be asked rxy, which is going to be our cross correlation. Usually we have rxx. Now since it is between two different processes, it becomes xy in nature. So we are to find rxy given sxy of omega. So we can see that this we are going to find rxy over here. If we want rxy, the input will be sxy. So we will keep these things in mind. Now considering the first quantity, I will have to look into what is the first point. I will have to find my limit of integration. So for an autocorrelation or cross correlation, the constant 1 by 2 pi has to be included in front. Please keep this in your mind. And since it is going to be inverse Fourier, the quantity is going to be positive in nature. So the sign is plus for exponential. Now I have mod omega less than or equal to 1. Modulus always varies between a positive range to a negative range. So the negative value will be minus 1, the positive value will be plus 1. So my omega ranges between minus 1 to plus 1. So this is going to be my quantity. Let me give it as input. So what will happen? I will have 1 divided by 2 pi, integral varying from minus 1 to 1. What is going to be the input? Sxy. Sxy has been given to us in the question as a plus I b omega. You have e power I omega tau in your formula for Fourier, and this is going to be integral with respect to d omega. So since this is a function of omega, we integrate it with respect to omega. This is going to be my first point. What is going to be the second hint, which we know whenever the function is going to be algebraic in nature? So what kind of function I have here? I have an algebraic function because it is in terms of omega, the variable. So what I'll have to do, the best way to solve is split this into an trigonometric form containing a cos and a sine theta. So in my step 2, what do? I consider this algebraic function, and for the sake of ease, what do? We split this exponential function which is available over here as cos omega tau. Since it is positive over here, with I write plus I sine omega tau, okay, into d omega. So this is going to be my step number 2. Whenever we have an algebraic input, just convert this exponential as cos and sine. This will make the problem a little easy for us in the coming process. Okay, now what do we have next is, let us expand the function. 1 divided by 2 pi, integral from minus 1 to 1. I have a plus I b omega. This is a complex number. It is of a plus I b. So, and this again is a complex number because I have cos omega tau plus I sine omega tau. So we are considering the product of two complex numbers. Now we will try to expand them so that it will be easy for us to split as even term and odd term. So what will I do now? I will first multiply this a with cos omega tau. So what will I have? A cos omega tau d omega. What will happen to the second term? Next term, I multiply this a with I sine omega tau. So what will I have? I is a constant, so I will have minus 1 2 plus 1 a sine omega tau d omega. Next, what will I do? I will have this ib omega to multiply with this first term cos omega tau. So what will I have? This I is a constant, b is a constant, so I will have it as integral minus 1 to 1 you have cos omega tau. And now in the last stage, what will I do? ib omega, let me multiply with this second term I sin omega tau. Now I have I here, I have I here. I into I square. What do we know about I square? I square is going to be equal to minus 1. So what will happen? I will have minus integral from minus 1 to plus 1 b omega sin omega tau into d omega. So this complex number, and I multiply with this complex number, two real parts and two imaginary parts, make it totally as 4 parts. So I have split the problem now as 4 parts. Now I can see what is the integral limit which have been given to me. It is minus 1 to plus 1. So from 0, this is going to be a symmetric limit. So whenever I have a symmetric limit, I can talk about the function being even function or odd function. What will happen to my function between a to a, f of x, if it is going to be even? If it is even, it becomes twice integral from 0 to a f of x dx, and when it is going to be odd, what will happen? The function will vanish for an odd function. So this will make the formula or the problem very easy for us to solve for. So we will go and check what kind of function we have been given with. A is a constant, I can put it outside. Cos theta is going to be an even function. So even function between minus 1 to 1 will become 2 times of 0 to a. A being a constant, take it outside. Sin omega tau. What is sin theta? Sin is an odd function. So what will happen to an odd function in the interval minus a to a? This odd function will vanish in the interval minus a to a. Now see, the problem was first very big, but now after the terms are vanishing, the problem will become very, very small. Now b is a constant, we have taken the b outside. What we have over here is going to be, sorry, I missed this omega over here. So I have b omega I into b omega cos omega tau. I into b omega cos omega tau. This cos is going to be, when I replace cos with an minus cos, so what will happen? This is going to be an odd function. And now how about cos? Cos is going to be an even function. So when I replace omega with minus omega, this will be giving me a minus omega, so it is an odd function. When I replace omega with an minus omega, cos of minus theta is going to be cos theta, it is an even function. When I multiply odd with even, what will happen? I will have odd function. What will happen to an odd function? Odd function vanishes. So this part will become 0 for me. Okay, see, second term also became 0. So now we will go on to this omega. This omega is going to be an odd function. Sin omega tau, sin when I replace with minus theta will become me minus sin theta. So this is also an odd function. Keep in mind, when I multiply odd into odd, you will get an even function. So this function will become twice integral from 0 to a. So out of the 4 different terms, only the first term and the last term exist and the remaining 2 terms vanishes. So in the next stage, what we are going to do? We are going to simplify these 2 terms. Okay, so what we have over here is 1 by 2 pi integral from minus 1 to 1. The first term which exists is a cos omega tau d omega, and the last term which existed was, so 1 by 2 pi, this was 1 by 2 pi was common to both of them. So minus 1 to 1 b omega sin omega tau. So I have integral from minus 1 to 1 b omega sin omega tau into d omega. Now we are ready for integration. So it is 1 by 2 pi. This a is a constant. take it outside. Integral cos theta on integration gives us sin theta, and integration with respect to omega. So what is going to be this part? This part is going to be my constant. So what I'll have to do? I'll have to divide by my constant. So it becomes a sin omega tau divided by tau. This has to be applied the limit between now this being an even function. What I'll have to do? I'll have to just rewrite this. So we will do that first. This lower limit, let me make it as 0, so that this becomes twice integral from 0 to 1. How is it? I know the property minus a to a is becoming twice integral from 0 to a. Now what will happen? This 2 comes outside, 2 can be very well cancelled off. I have a sin omega tau by tau. So now the limit is just between 0 to 1. So the first term is over for me. Now 2 which has been brought outside can be cancelled off. I have b which is a constant. Omega is an algebraic function, sine is going to be a trigonometric function. Both are of different types. So when I have to integrate, I will have to use u is equal to I late. So which is going to use integral u dv method, or we best call it as Bernoulli's method. So what we'll have to do? Keep your u, which is going to be algebraic, which comes first. U is equal to w or omega. So keep your omega as such. dv has to be integrated. Sine on integration gives you minus cos omega tau divided by what is going to be the constant. Constant is going to be my tau. So first term is over. Second term, negative, positive, negative, positive, negative alternatively. Omega on differentiation gives you 1. Cos on integration gives you sine. But since there is already a minus sign, this minus sign sticks on over here. Sine omega tau divided by tau. One more tau will come, so this becomes tau square. Third term is positive, but 1 on differentiation makes it as 0. So the process ends over here between 0 to 1. So I end the differentiation an integration process using Bernoulli method. So now we are ready to apply the limit. What I have is 1 divided by pi, which is outside. Now apply the limit a. So what takes the upper limit and what takes the lower limit over here? So the upper limit is taken by the variable. Omega is going to be the variable which takes the upper limit, and the lower limit. What do we know about sine 0? Sine 0 is going to be equal to 0. So there will be no lower limit that exists for me. So just the upper limit which exists for you gives you sine. Omega takes the value 1. So it becomes sine tau divided by tau. So my first term is over. Now in a similar fashion, when we go over here, what will happen when omega takes the upper limit? It becomes equal to 1. What will happen when omega takes the lower limit 0? It will become 0. So omega on taking the lower limit, what will happen? It will become 0. Sine, when it takes the lower limit 0, what do you know about sine 0? Sine 0 is 0. So again, for both the cases, both the terms, the lower term doesn't exist, only the upper term exists. So we have only half the problem. Only upper limit is going to exist for us, and the lower limit is vanishing for all the term entirely for the entire problem. Okay, so now we are ready for the evaluation. Minus into minus will become plus. Omega takes the value. Omega is being substituted for the upper limit 1. So over here also omega takes the upper limit 1. So I have it as b cos tau divided by tau. So this is my second term. Now getting back to the third term, 1, 2, 3. 3 negative signs, so it becomes negative sign. B times, now again, which takes the upper limit? Omega takes the upper limit as 1. So what I have over here is sine tau divided by tau square. So I see that nothing can be crossed off, or no more simplification can be made to this stage. So I leave the problem as such and say that we have found out what is the requirement. The cross correlation R x y of tau. Okay, So we will quickly have a recap of the quantities which we made. So we just saw dear that we had a cross power spectral density which was in no way different from a power spectral density. Only change that happened was in the formula, where instead of xx I had xy, and similarly here also in the formula you have xx, you have xy. Apart from that, all the process remains to be the same. First take care of your limit, break open the modulus from negative to positive, and now since the function is algebraic, you can split it into cos and sine. The third part, whenever you have cos and sine, we can talk about even and odd function, and in after your step 3, what will happen? All your odd functions will vanish and even functions will become 2 times of the integral. So in your step 4, you can go for your twice integral, and then you go apply your Bernoulli's formula. After the application of Bernoulli's formula and the limit, both almost all the lower limits vanish for omega value to be equal to 0. Just your upper limit exists, substitute the limit for your variable omega, and then complete the process. That's it. Thank you.